Hi friends, welcome to our channel. Let's have a look at problem 3567, minimum absolute difference in sliding submatrix. In this video, I'm going to solve this problem using brute force. For this kind of problem, actually, we can use vectorization. However, I feel that here it's important to we can do it using brute force. So with that said, let me first make several points. First is the result shape, right? So here we have m by n integer matrix, and then we use key by key submatrix grid, right? So the output will be this size, m minus k plus 1 and n minus k plus 1. So this can be easily understood, right? For example, if you have say length, so let's say one, just make some dummy one, and this length is 5, right? So if we have a window, so here I'm using one dimensional, so the kernel, let's say, is say 1 1 1, right? Then you look at this one, this is the 1, and then you shift to the right one more, and then you shift to the right one more. So the kernel size here, you don't need to care about the 1 1 1. So the kernel size is 3, so here the length is 5. So the result will be n, the length minus the kernel size plus 1. So here is 5 minus 3 plus 1. That is 3, right? So 3 windows. For example, if we want to compute the inner product, or with respect to 1 1 1, in other words, you want to compute the sum of the 3 consecutive elements, you are going to get, say, this will be 6, then this will be 7, and then this will be 10, right? So that's, one dimension, right? So here, if you look at the row, so we have m rows. So this is the k, the size. So then we are going to have m minus k plus 1. So this m is the length corresponding to the n here. Size is k, and this 1. So similarly for this second dimension, right? So we n minus k plus 1. That's the return. So another thing I want you to notice is that if all elements in the submatrix have the same value, then the answer will be 0, right? This in particular applies to one element case, right? If your k is 1, right, you just consider 1 by 1 submatrices, right? So this is also very important. So you can actually examine the output 1, 2, and 3. But here we are not going to do that. Now let's look at coding. So personally, I feel for this problem, we can use vectorization. For example, you can use NumPy, or you can look at some implementations by PyTorch. And so this actually also related to, the convolution neural network kernels. So that's maybe regarded as an application. But here, I guess, some people might know the advanced implementations, but not know the brute force one. So here I'm going to use the brute force one. So I have changed this to be a capital A just for convenience. So let's get the m and n. So using the convention in this problem, so A naught, right? So m is the number of rows and n is the number of columns. So we are going to initialize like this. So 0 times so n minus k plus 1 for dummy index in range m minus k plus 1. So here, because if you look at one single element, it's immutable, it's an integer. So you initialize an array of length n minus k plus 1. That's no problem, right? But here, after you initialize this one, you cannot put times this m minus k plus 1, right? Actually, that will, because the things are mutable, so you will change accordingly. If you change one, all the others will be changed. That's why here we should use this scenario, right? Because each one is a different instance right, of this n minus k plus 1 array. So this is also very important, I guess, right, especially for beginners. So now let's look at the computation. So here for I in range, say m minus k plus 1, and then we want to use those rows, right? So a t for t in range, say I, so starting from I and then ending at I plus k minus 1, right? We write I plus k. So this range contains key rows, right? This is the key rows we're going to use. And then let's look at j. For j in range n minus k plus 1, right? So what we want to inbound actually is those. So for those rows here, so from j to j plus k, right? So here for row in rows. So now we have our inbound elements. So here, because we want to compute the minimum absolute difference, so we need to do some sorting. So here, actually, if you look at some solutions, you can introduce sorted list. But here, because of the size of the problem, which is small, so I can just use a sort, right? So let me first do this. I'll initialize a set, right? Because I want to delete the just remain unique elements. So here I'm going to do from for item in inbound, right? So I'm going to do temp union with another set. So this set is item. So notice that item itself is a list. So here I use a type conversion, right? So then we get the full numbers as a set. So now I'm going to sort it. So temp, because it's a set, we cannot use a sort method. So we're going to use sorted built-in function. So we get this. So here, in order to get the mean gap, first I'm going to do this. Set mean gap to be float infinity, right? So because we are going to compute mean, so we initialize a very large one. So next, what we want to do, if length of temp equals 1, it means all the numbers are the same, right? As here, so we want to have 0. So we're going to do result ij equals 0. This is set to be 0, right? So this is the one. And if length, actually temp, is greater than 1, so it's better to put this guy. Let me copy this. Copy this line here. Let's delete this one. So if the length is greater than 1, then so for s in range, so from 1 to the length of temp, so we can compute the gap, mean gap. So this will be mean of the previous state, and so temp s minus temp s minus 1, right? So once we have this, after this for loop, so we are going to get the mean gap, right? So then actually we can just set it. So result ij equals mean gap. If mean gap is less than float infinity. So this I write very carefully. So if this just a 0, right? Then so you can do the return. Let me first run it to make sure it works. Yeah, it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the cases. So here, let's see. I can because I have distinguished this situation. If we use this one, if it works. Well, it's not right. So we need to have this one. Yeah. So with that said, I guess that's basically about it for the coding part. So the reason we do this video is that for this kind of problem, I guess solving it using advanced techniques might be easier bias than solving using brute force. So here we present a brute force way, right? Actually, sometimes if you can solve a problem by pure brute force, it actually demonstrates the ability of coding. So with that said, that's it for the current video. Thank you for watching.